Welcome to the Deep Dive. Today, we're looking at a really interesting set of materials. We've got conversation transcripts, a formal training invitation, even a detailed syllabus.
That's right. And they all revolve around the specialized project management software called Spider. Our mission, really, is to get under the hood of an intensive training program designed for it.
Yeah, we want to understand the who, the what, the why. Who's being trained, what exactly are they learning, and why this specific software, this specific approach.
Exactly. We're digging into the participants, the core content, which seems very focused on scheduling and planning what they expect people to actually do afterwards, and, the brass tacks of the invitation itself.
And this isn't just about clicking buttons in a new program, is it? The sources suggest it's about a fundamental shift.
Oh, absolutely. It's about shifting mindsets, moving away from just planning based on time, which, let's be honest, can be a bit theoretical sometimes, towards planning based on actual real-world resource constraints. What materials, what people, what money do you actually have available?
Which is super relevant for their context, right?
Yeah.
Engineering, construction. I think it's in Ghana.
Precisely. A rapidly growing market, construction projects, environments where limits on resources are just a daily reality. This isn't planning in a vacuum.
Okay, so let's start with the people involved. The context seems to be colleagues talking about needing to learn Spider because it's not the usual tool there.
Right. In Ghana, the standard seems to be Microsoft Project. Spider is something new they're bringing in. And there's a specific construction project lurking in the background.
Lurking.
Well, it was paused financial constraints, it seems, but the sources say it could restart anytime, maybe next month, December, maybe early next year, like February.
So there's some real urgency to get people up to speed now.
Exactly. Which brings us to the two main participants in this training, Joseph and Mamani.
Okay, tell us about Joseph first. He sounds like he's got some serious experience.
He does. He's a civil engineer, been with the company for a decade, actually just starting his 11th year, so definitely has skin in the game.
And his role, is he a planner already?
That's the key thing, no. His background is primarily in execution production management, actually getting the work done on site, not so much the detailed scheduling or monitoring side of things.
So has he used Spider before at all?
Very little, apparently. He mentioned maybe 3 or 4 times. And it wasn't structured learning. It was more like looking over his colleague Tiago's shoulder, reviewing printed schedules, maybe making a couple of quick tweaks while sitting with Tiago. So exposure, yes, but no real foundational understanding of how it works or its methodology.
That's a crucial distinction. So even with 10 years at the company, he felt he needed to start from square one.
Explicitly. The transcripts show him insisting on joining the training from the beginning with Mamani. He recognized his previous encounters weren't, proper basic training. He lacked the structure.
Okay, so that's Joseph. Experienced engineer, execution-focused, needs the fundamentals. What about Mamani?
Mamani's also a civil engineer. He actually worked at the company before for about 6 years, left, and just rejoined last month in September.
Okay, so he knows the company. Does he know Spider?
Nope. 0 practical experience with Spider. Complete blank slate there.
Wow. Any project management software background at all?
He mentioned having some theoretical knowledge of MS Project, but only from taking courses on Udemy or watching YouTube videos, so he gets the idea of scheduling software.
But hasn't actually used it on a real project.
Exactly. And his only knowledge of Spider before this was apparently seeing what the interface looked like on YouTube after someone mentioned the name.
Okay, so this is quite the teaching challenge, isn't it?
Yeah.
You've got one guy with years of practical site experience but unstructured software knowledge, and another guy who's theoretically aware but practically a complete beginner.
It really is. The training has to bridge that gap. It can't be too basic for Joseph, but it absolutely has to start at the basics for Mamani.
So the plan had to be
Oh,
start from scratch for everyone.
Pretty much. The sources quote the instructor aiming for the basic course for Mamani, including topics for Joseph. It needed that comprehensive foundational start, but structured in a way that even Joseph would find valuable for filling in his own gaps.
Makes sense.
Yeah.
Okay, so we understand the who and the why now. Let's tackle the bigger why. Why Spider? If MS Project is the standard locally, why go through all this effort and expense?
Now we get to the core philosophy. It seems to come down to perceived flaws in the standard tools, particularly MS Project.
Okay, lay it out for us. What's the critique of MS Project according to these sources?
Well, they call it not a very strong application, specifically because it mainly tracks progress using percentages and time elapsed, like days.
Right. Task X is 50% complete.
Exactly. But the crucial missing piece, they argue, is tracking based on quantity production. How many actual units of work were completed? How many cubic meters of concrete poured? How many bricks laid?
Okay, I see the difference. So if you're supposed to pour 100 cubic meters today, but you only manage 70, how does MS Project handle that versus Spider?
With MS Project, you might report, well, you could report 70% complete based on volume, or maybe you report based on time spent, say, 80% of the day was used. It allows for, let's say, interpretation. It makes it easier to, as the source puts it, lie, or perhaps just be overly optimistic about progress.
So the schedule might look okay, green even, but the actual physical progress is falling behind, and it's masked by percentages.
Precisely. That disconnect can build up and cause major problems down the line. Spider, on the other hand, apparently forces you to input the actual quantity achieved. If the plan needed 100 and you did 70, you put in 70.
And then what happens?
Then the software immediately recalculates the impact of that shortfall on the rest of the schedule. The delay, the impact on the critical path becomes visible right away. You can't just smooth it over with a vague percentage.
It forces a confrontation with reality.
That seems to be the idea. It makes performance, or lack thereof, transparent.
And this focus on tangible output and limitations, you mentioned it links back to Spider's origins.
Yeah, this is fascinating. The sources draw a direct line from Spider's core philosophy back to its development, apparently in the Soviet Union or similar restricted economies.
Okay, explain that connection. How does software from that historical context fit into a modern, growing market like Ghana's?
Because it was fundamentally designed from the ground up to plan based on constraints. It starts with the assumption that resources, money, people, materials, even time are limited.
So it asks, what can we realistically achieve with what we actually have?
Exactly that. The instructor even contrasted it directly with tools like Primavera or MS Project, suggesting, quite pointedly, that they were created for rich people without any problem of resource.
That's quite a statement. So the idea is that those tools assume you can always throw more money or people at a delay.
Sort of, yes. They facilitate planning based on desired timelines, perhaps assuming resources can be found. Spider flips that. It forces the plan to conform to the available resources.
This sounds like the resource-constrained scheduling, RCS concept they mentioned.
That's the one. It's central to Spider. RCS basically says your schedule can only progress as fast as your most limited resource allows. If you need 5 excavators but only have 3, the schedule must reflect that reality. It models the necessary delays caused by bottlenecks.
Which makes it incredibly valuable in places where those bottlenecks, material shortages, equipment availability, skilled labor limits are common.
Precisely. It grounds the schedule and feasibility from the start rather than letting it be an optimistic wish list.
Okay, so that core philosophy is a huge driver. What other Spider features make this training worthwhile? They mentioned cost integration.
Yes, that was highlighted. Unlike MS Project, where cost management often happens in separate spreadsheets, Spider is apparently very advanced in integrating cost directly into the schedule model itself.
So every task, every resource usage carries its cost implications within the plan.
That's the picture painted, yes. Given that the project was paused due to finances, having that tight cost integration directly in the schedule would be, well, pretty essential, you'd think.
Makes sense. What else stood out? There was something about web publishing.
Ah, yes. The web publishing and communication feature. This got quite a bit of positive attention in the conversations. It's about making the schedule accessible.
How does it work?
Basically, the planner, like Tiago, can upload the complex Spider schedule to a secure website. Then, other team members like Joseph or Mamani, or maybe even managers or clients who don't have a full Spider license.
Which can be expensive, presumably.
Right. They can log in through a standard web browser, view the Gantt chart, scroll around, zoom in, see the plan.
Okay, viewing is useful.
Yeah.
But they mentioned communication.
This is the clever part. Those viewers can actually provide feedback or updates directly into designated fields on that web view. Maybe Joseph wants to report progress on his task, or Mamani has a question about a dependency.
Wait, so people are editing the master schedule via a web browser? Doesn't that risk messing things up?
No, and that's the smart design. The feedback doesn't automatically change the master file. It gets downloaded instantly into the main Spider file back on Tiago's machine. I see. He, as the planning manager, then reviews the incoming feedback, the progress updates, the notes, and decides whether to accept or reject them, incorporating them into the official schedule.
So it maintains central control, but streamlines the feedback loop enormously. No more emailing files back and forth or marking up PDFs.
Exactly. It turns the schedule into a much more dynamic, collaborative hub. As Joseph noted, it allows a lot of people to do the same thing at the same time in terms of providing input.
And security. Can everyone see everything?
No, that's also handled. Access is controlled by individual logins and passwords, and the planner can configure what each user can see.
So you could hide sensitive data.
Definitely. You could block the cost columns for certain users, or maybe limit visibility on resource allocation details. So Joseph might see the timeline and dependencies, while maybe a project manager sees the cost too. Granular control.
That's powerful. And this ties into the accessibility point, right? The free viewer.
Yes. Unlike MS Project, where you often need a license just to open a file, Spyder provides a completely free viewer application.
What can it do?
It lets anyone open, view, print, and adjust the layout of a Spyder file. But crucially, you cannot make any changes to the data or the schedule logic. It's purely for viewing and understanding the plan.
Democratizes access without risking the integrity of the plan.
Okay.
And for the training itself, they're not using the full professional version.
Correct. They'll be using the academic edition. The sources describe it as functionally complete, same screens, same features, but limited to 200 activities.
Plenty for learning exercises, I imagine.
More than enough to get hands-on with all the core concepts and practice extensively before they need the unlimited professional version for the actual large-scale project. The Pro version requires a physical hard lock, like a USB key.
Okay, so we have the context, the people, the tools, philosophy. Let's get into the training itself. How is this 12-session course actually structured to instill this different way of thinking?
It's very deliberately structured. It's explicitly labeled a basic level course focusing only on scheduling methodology. They've intentionally cut out the more advanced project control topics for now.
Build the foundation first.
Exactly. Nail down the scheduling logic and resource constraints before worrying about tracking variances later.
And the format. It sounded pretty intense.
It is. 12 online classes crammed into just 4 weeks. They meet 3 times a week, Monday, Wednesday, Friday.
That's a demanding pace.
It is, and you have to appreciate the instructor's commitment here.
Mm-hmm.
The classes are set for 8:00 a.m. Ghana time.
Okay, and the instructor is where?
Brazil, which means it's 5:00 a.m. for him. Starting a detailed technical class at 5 a.m. that shows some serious dedication to making this work across time zones.
Wow, yeah. That definitely underscores the importance they're placing on this. What about the teaching style? Is it just lectures?
Oh, absolutely not. The whole thing is designed to be practical, hands-on. The rhythm they described is information or lecture session on Monday, Wednesday, or Friday, followed immediately by a short targeted exercise that's due the next day. Tuesday, Thursday, Saturday.
Forces immediate application. No time to forget.
Right. But it's the philosophy behind those exercises that's really interesting. It's not about just checking boxes.
What do you mean?
The instructor's explicit principle, quoted in the source, is, the exercise must make you have problems, because if you don't have problem, you're not going to find a solution.
Okay. So they're intentionally designing exercises to be tricky, to make the students struggle.
Essentially, yes. Not impossible, but challenging enough that participants have to grapple with the logic, confront the constraints, maybe make mistakes, and then figure out why Spyder reacted the way it did. It's learning through structured problem solving.
That sounds intense, but probably very effective for deep learning, like building muscle memory for the brain.
That's a good way to put it. Okay, let's walk through the syllabus blocks quickly. Block 1, setting navigation and fundamentals.
This is the onboarding, right? Getting comfortable with the interface.
Exactly. Lesson 1 is basic navigation, understanding the main screen as the command center. Lesson 2 is all about using the Gantt chart, viewing, zooming, seeing how the model responds.
And lesson 3 focuses on the status bar. Seems minor.
But critical.
Yeah.
It's about building good habits. Checking the status bar before you calculate the schedule lets you catch errors, wrong calendar settings, missing resource limits. It prevents those oops moments that can mess up the whole calculation. Preventative maintenance for your schedule.
Got it. Then block 2, structured data organization and communication, moving beyond just viewing.
Right. Now they learn to manage the data. Lesson 4 is selecting, sorting, filtering, essential for finding specific information quickly, like show me all tasks missing a resource.
And for communicating effectively.
That comes in Lesson 5, using layouts and graphs for clear visual communication. And then Lesson 6, which is the big one we discussed, views and publishing via the web server, how to package information and share it collaboratively.
And how does Block 2 wrap up the organization part?
With Lesson 7, modeling the scope using the work breakdown structure, WBS, that hierarchical breakdown of the project, and Lesson 8, configuring activity types for consistency, setting the structural foundation.
Okay, on to Block 3. From scope to time logic. This sounds like the core scheduling engine.
It really is. Lesson 9 is all about dependencies, the links between tasks. Mastering not just the basic finish to start FS, but also start to start, SS, finish to finish, FF, start to finish, SF, and using lags correctly.
Why is mastering things like start to start so important? Isn't finish to start usually enough?
In simple plans, maybe. But in construction, things overlap. You don't wait for the entire foundation slab to be 100% finished before you start erecting steel on the completed sections. SS allows you to model that realistic overlap. Task B can start shortly after Task A starts. Using these correctly makes the schedule shorter and more realistic.
Okay, so you build this complex web of logical links. Then what?
Then Lesson 10. Calculate the network. You hit the button, and Spider crunches the numbers based on those dependencies. This is where it identifies the critical path, the sequence of tasks with zero slack, where any delay impacts the project finish date, and calculates the float or clearance on non-critical tasks.
So this step turns the logical map into an actual timeline with critical points identified.
Precisely. It validates the logic and gives you the time-based structure.
Which leads us finally to Block 4, feasibility of the model, bringing reality back in.
And this is where the Spider philosophy really bites. Lesson 11 is all about recognizing real-world limitations, the number of skilled teams available, specific work calendars, maybe equipment is down for maintenance certain days, even physical space constraints on a crowded site.
So you overlay these constraints onto the calculated schedule.
Yes, and you engage resource-constrained scheduling, RCS. If your initial calculation says you need 10 electricians on Tuesday, but Lesson 11 forces you to admit you only have 5 available.
Then RCS has to adjust the plan.
Exactly. It will push some of that electrical work that requires the extra 5 electricians to Wednesday or Thursday or whenever they become available, automatically recalculating the downstream impacts. The schedule gets longer, maybe, but it becomes actually doable.
So participants learn to create schedules that aren't just logically sound, but physically achievable with the resources they have.
That's the goal. It moves planning from theoretical to practical.
And the final step.
Lesson 12, risk analysis and final feasibility. They introduce some basic uncertainty analysis, testing how robust the schedule is. Does a small delay cascade? How reliable are the finish dates? It's about validating the executable nature of the final plan before signing off.
Wow. Okay, that is a seriously thought-out curriculum. It's clearly designed to rewire how they approach planning. So after these 4 intense weeks, what should Joseph and Momani be able to do?
The expected outcome is practical proficiency in 3 key areas. First, hands-on resource-constrained scheduling, building feasible plans. Second, rigorous feasibility analysis, being able to vet a plan before work starts. And third, setting up for performance monitoring based on actual quantity output, not just percentages.
Skills directly applicable to their challenging construction environment.
Absolutely. They should be able to produce schedules that are not just hopeful timelines, but reliable predictions based on known constraints. That's a direct line to better project outcomes.
And this whole effort is formalized in that training invitation we saw. What were the key details there?
Well, it's formally titled Basic Spider Project Training 2025. It's not free. There's a fee of US $1,000, specifically noted as being for 2 seats for professionals.
2 seats presumably for Joseph and Momani.
That seems the clear implication. And significantly, it's not just open enrollment. It requires an interview and approval first.
So they're screening participants.
Looks like it. They want people with relevant practical experience who are committed, not just casual learners. And tying back to that project potentially restarting soon, participants needed to confirm this week. Real urgency there.
Okay. Now, there was one more interesting thread in the sources, a longer-term vision. Beyond just training these 2 individuals, something at universities.
Yes, that was quite forward-thinking. A discussion about potentially introducing spider planning courses into Ghanaian universities, specifically targeting civil engineering departments.
Why? What's the gap there?
The point made was that most Ghanaian engineering programs currently either teach only very basic MS project or sometimes no formal project planning methodology at all. The idea is to establish SPIDER, with its resource-constrained focus, as the standard, more robust methodology taught academically in the region.
That's ambitious. How would they make that sustainable? They can't just have the expert fly in forever.
No, and this is where the resource-constrained thinking applies to the education model itself. They proposed a tiered tutor system.
How would that work?
Step 1. The expert teaches the first class, maybe 20, 25 students. But a key goal of that class is to identify the sharpest students who could become future tutors.
The trainer approach baked in from the start.
Exactly. Step 2. The next class relies more heavily on the course materials books, manuals focusing on embedding the methodology. Step 3. The class is primarily taught by those newly identified student tutors, with the original expert just providing some oversight.
Okay, building local capacity.
And then, step 4 and beyond. The university takes over completely. They use the established tutors, the course materials, the handbooks, and critically, the free academic edition of the SPIDER software.
So the expert essentially makes themselves redundant over time.
That seems to be the goal. It's about transferring the methodology and creating a self-sustaining system, rather than creating a permanent dependency on external paid instruction. It uses the university's own resources, smart students as tutors, free software to scale the knowledge.
That fits the SPIDER philosophy. Perfectly achieve the goal using the available constrained resources. Very clever.
It really is. It prioritizes embedding the knowledge over long-term commercial gain from teaching.
Was there anything else logistical mentioned? Something about the software download.
Oh, just a minor practical point. They confirmed the academic edition file would be sent, but the instructor added a small caveat. Because the software originates from a Russian development team, sometimes international downloads, even small ones, can be unexpectedly slow. Just a little reminder of the global realities of software distribution.
Okay, so wrapping this deep dive up, we've gone from the specific needs of two engineers, Joseph and Momani, needing a solid scheduling foundation.
All the way through a highly structured, problem-based training curriculum designed around a software, SPIDER, that fundamentally prioritizes real-world constraints over theoretical timelines.
And the core takeaway seems to be that philosophical difference, doesn't it? SPIDER is built for a world where resources are limited time, money, people.
Exactly. It reflects the messy reality of many projects, especially in engineering and construction, far better than tools that might implicitly assume resources are infinite. The training aims for a shift in planning approach, not just software proficiency.
And the training method itself mirrors this, forcing participants to confront and solve problems related to those constraints, making the learning stick.
It's about building that critical thinking muscle alongside the technical skill. Identify the limits, model the solution, execute realistically.
So thinking about this whole structure, the focus on constraints, the problem-solving approach, the goal of self-sustaining knowledge, it leaves us with a question for you, the listener. Are the tools and methods you currently use based on an assumption of unlimited resources? Are you building plans destined to break against reality? What critical constraints in your world might demand not just a different tool, but a fundamentally different way of thinking about the problem itself?